So next topic is basic stat definition. So first one is mode, most common value in a data set. Next is median. Median is the middle value in a data set. Like if we say data is 1 to 11, so 6 will be the median. And what's the mean? Mean means the average, that sum of all the observations or values are divided by the number of values. So what is standard deviation? So standard deviation is the dispersion in the data. It's mostly in the parametric data which follow the Gaussian curve. There is a central value which we called median. So any dispersion around the median, it will be measured. So if we take one standard deviation, it covers 68% of the population, and if we talk about two standard deviation, it covers 95% of the observation. Next is the standard error. The standard error means the standard deviation of the sample mean. Standard deviation of the sample mean. Next is the confidence interval. So confidence interval, it's in simple word, it's measure uncertainty in the measurements. And as I said, that 95% means 95% of the population are in the CI, and this is the mostly studies use this CI 95%. And larger the sample is, smaller the variability, and more likely the results are true. When quoted alongside a ratio, that then a relative risk or odd ratio can be predicted, and interval including one is not in when comparing two groups. Next is prevalence. Prevalence is the result of occurrence of new cases over a period of proportion of population with the disease at a given time point. And next is the incidence, rate of occurrence of new cases over a period of time. Then is the odds, number of times an event is likely to occur, divided by number of times it is likely not to occur. So it's chance. Odds of having a girl is 1 by 1, that's equal to 1. And then is odds ratio. The odds of having the disorder in the experimental group relative to the odds in favor of having the disorder in the control group. So odd ratio is equal to 1, so no effect. Odd ratio is more than 1, higher chance of disease in the exposed group. So if odd ratio number is more than 1, it's mean experimental group which was exposed to the risk will have a disease. So if odd ratio is increasing, it's mean factor has a good relation with the disease. And then is the risk, probability of something happening. This is a general definition of the risk, and how we calculate number of times that an event is likely to occur divided by total number of events possible. So risk of having girl 1 out of 2, 50%. Then is absolute risk, incidence rate of outcome in the group. Then is relative risk, experimental absolute risk divided by control absolute risk. So relative risk is equal to 1 minus no risk 1, no risk of difference. Relative risk more than 1, greater risk with the exposed factor. As we said, odd ratio more than 1, more chance of having a disease with that factor. Relative risk less than 2 factor is protective. Number needed to treat, the number of subjects that must be treated for one extra person to experience a benefit. It will be for risk calculation in the people or screening. Then is the hazard. Then is the hazard mean instantaneous probability of an endpoint event, degree of increased and decreased risk of a clinical outcome due to a factor. Then is the hazard ratio. So more than 1 factor increases the chance of outcome, less than 1 factor decreases the chance of outcome. Then is very important, null hypothesis. So null hypothesis, one of the professors in the course told that null hypothesis means as a statistician you don't consider anything in your head. Null hypothesis for a statistician means everything is equal. Any test is equal sensitive, equal specific. Any study has equal impact. So null hypothesis means any difference between the two study group is chance or 0. So what is p-value? P-value is again a very important thing. Probability of results given a true null hypothesis. Okay, in simple word, probability means what is that thing happen incidentally by nature. So in stat, the probability p-value of less than 0.05 is very important. The result due to the chance is less than 1 into 20. So p 0.05 means 1 out of 20 has a chance, 19% chance that it is true results. and this is a threshold for the statistical significance, p-value less than 0.05. Then is the type 1 error. Prof, according to the prof, type 1 error means that the null hypothesis was true but falsely, but false positive. So it's mean thing wasn't real, but they cooked it, they make it up, they made it up. So null hypothesis is rejected even when it's true. And due to bias, so this type 1 error mostly happened due to the bias and confounding variables. And type 2 error called beta error, it's a false negative, that here null hypothesis was true, was false, but it is accepted as a true. So it's mean that it's falsely negative. So null hypothesis is accepted when even it is false due to sample size that's too small. So type 2 error can be prevented by increasing the sample size, and type 1 error can be prevented by reducing the confounding variables in the bias. Then is intention to treat analysis. All the patients are included in the analysis regardless of whether they completed the study. So if not accounted for it, it leads to attrition bias. Dropout increase the chance of type 1 or type 2 error. So power, this is again a very important question. What is the power? Ability to detect a true difference in the outcome between each arm. So probability that a type 2 error will not occur due to increasing the power of the study, and the larger the sample size, the greater the power. The power of 0.8 is 80%. The probability of finding a significance different if one existed having excluded the role of chance. So power is equal to 1 minus type 2 error, like so 80% power is a very good study. 80 or more than 80 is a very significant power study. So next topic is sensitivity. So again, prof told sensitivity means inclusion. Sensitive means inclusion, that true positive rate. So how we calculate a proportion of the subjects with the disorder who will have a positive results. So in this book there are two mnemonics they have given. One is snout and for sensitivity, and one is spin for specificity. So snout means highly sensitive test negative result will rule out the disorder. Okay, and next is specificity. So specificity means to make negative, so exclusion. So true negative rate, proportion of subjects without the disorder who will have a negative results. So spin is a highly specific test, positive result will rule in the disorder. Next is clinical endpoint. It's again a term used by the academic people. So what was the clinical endpoint? What was the endpoint of the study? Either mortality or disability or any other morbidity. Then is surrogate endpoint, outcome used as substitute for clinically meaningful endpoint. Then is the composite endpoint, that it has that initially it was only single, then there are a lot of other factors which been noticed during the study, they are included as well. So composite endpoint combines several measurements into an algorithm, overcomes underpowering. Primary endpoint is a health parameter measured in all subjects to detect a response to treatment, and secondary endpoint, other parameters measured in all subjects help to describe the effects of the treatment. So next is validity, extent to which a test measures what it is supposed to measure. This is called validity. And reliability, how consistent test is repeated measurements. This is called reliability. So validity and reliability, two different terms. The validity means extent to which a test measures what is supposed to measure. This is a valid test. And how reliability, you have to do 100 million times, this test will be very, very consistent. Okay. And next is the this is the last part for the definition, bias. So selection bias, understood that while selecting you recruit of unrepresented sample population, or sampling bias introduced by researchers, or response bias introduced by study population. Then is observation bias, result of failure to classify or measure the exposure or outcome correctly. And then attrition bias, number of dropouts differ significantly in different arms. Those left at the end, those people who lost follow-up at the end of the study, it's called attrition bias. So selection bias, observation bias, and attrition bias. And next, last but not the least, is the confounding factors. Confounder is associated with exposure, but not a consequence of the exposure. we are assuming that these results are because of this factor, but actually something else is producing that result in the study. It is also associated with the outcome independent of exposure. For example, not due to bias must be identified, so you can make measures to eliminate control confounded by with matching, and so confounding factors can be decreased by matching and randomization, and at the time of analysis by stratification, standardization, and statistical adjustment in multivariate analysis. Thank you.